Good morning, boys and girls, and welcome to Wednesday's lesson. Today we are working on Module 15, Lesson 2, Compare Fractions with the Same Denominator. If you turn to page 405 in your books, you can follow along and complete the lesson together. The I Can objective reads, I can compare fractions that are divided into an equal number of same-sized parts. So we already have a foundation in fractions and in comparing numbers. We've used greater than, less than, and equal to symbols to make comparisons. We've learned about numerators and denominators and what each one stands for. And we know how to compare numbers based on their values. Let's start with the build understanding. Number 1, both Rennie and Leah paint same-sized patios that are divided into 6 equal sections. Rennie paints 3/6 of his patio floor orange. Leah paints 4/6 of her patio floor pink. Who paints less area? Well, let's think about what this problem is talking about. So we should be making a movie in our head as I was reading it to you. So we know that there's 2 people and they're painting patios. A piece of important information, the patios are the same size. We know that each of the patios are divided into 6 equal sections. Rennie paints 3/6 of his patio floor orange. So 3/6 of it is orange for Rennie. And then Leah paints 4/6 of her patio floor pink. I don't have pink, so I will use red. So Leah paints 4/6 pink. And we want to find out who paints the less area. Okay, the least amount of space inside. A, how can you represent the areas that Rennie and Leah paint? Well, if we take a look at our models, we see that we have 2 models and they're the same sized squares. And that's really important, boys and girls, when we're comparing fractions. So we have Rennie's patio and Leah's patio, and we have to break them apart. How many parts are we going to break each patio into? That's right, 6. The problem tells us 6 equal sections. So I'm going to go ahead and as evenly as I can, I'm going to divide the patios into 6 equal sections. Okay? And now let's shade them in to represent how much each person painted of their patios. So for Rennie, I know that we're using orange, or he's using orange, so I'm going to go ahead and label 3/6 on the side. I know that he paints 3 out of those 6 equal parts in orange. And I'm going to go ahead and shade it in. That's 1/6, 2/6, and 3/6. And then Leah, who's painting in pink, I only have red, she paints 4/6. So I'm going to go ahead and shade in 4 out of those 6 parts. 1/6, 2/6, 3/6. That would be the same amount. And now I'm shading in an extra 6, 4/6. That makes it very easy to compare my 2 models. They're the same size, they're broken up in the same way, so now I can easily compare them. I can see that 4/6 is a larger area. There's more painted in Leah's patio than in Rennie's. So if I'm using my symbols, I'm going to say that Rennie's patio is less painted than Leah's patio, and I would put less than. Okay, so let's look at B. Who paints less area of the patio? How do you know? Well, I know that Rennie paints less, and the reason I know that is because 3 parts out of 6 is less than 4 parts out of 6. It's 1/6 less, it's 1 part less. So Rennie paints less. Okay, and I used my model, and I could compare my model. C, write less than, greater than, or equal to. 3/6 blank 4/6. Well, 3/6 is less than, and we remember that the symbol for less than looks like this. So I'm going to go ahead and put that symbol into my problem. Now, boys and girls, make sure you can remember any of those little tricks that you've learned. The alligator mouth or the Pac-Man is pointing to the bigger number or the bigger quantity. I just don't want to see any teeth in your symbols. Remember, this is it's still a math symbol, okay? So that's a great way to remember it, but then when you're writing it, you're showing me the actual symbol. Let's move on to number 2, and to help us out with number 2, we have Tyler. Hi, Tyler.
Hello.
Okay, so Tyler, I'm going to read the problem. I want you to make a little movie in your head so that you know what the situation's about. Okay, Ellen's desk is 7/4 yards from the wall. Ethan's desk is 3/4 yard from the wall. What is that problem about? What is it telling you?
I think it's telling me that there are 2 desks away from the wall.
Okay, good. What quantities do you see in that problem?
For Ellen's desk, I see 7/4.
Good. And the 7/4 represents the distance in yards that her desk is from the wall. And what other quantity do you see?
For Ethan's desk, 3/4.
Okay, good. And the 3/4 represents the distance in yards that his desk is away from the wall. So A, how can you show each distance using fraction strips and a number line? So over here on the top, I have fraction strips. How can I use these to help me to compare my 2 quantities?
Well, you can put their names for each fraction.
Okay, so let's make this one Ellen's, and let's make the bottom one Ethan's. Okay, and how would I represent Ellen's measurement?
You would shade in 7/4.
Okay, so I'm going to shade in 7 of those parts. So 1, 2, 3, 4, 5, 6, 7. So 7/4. And what would I shade in for Ethan?
3/4.
3/4. So I'm going to go in here and I'm going to shade in 1 part, 2 parts, 3 parts. Okay, so now let's look at our number line, and I'll do that in a different color. How can I show each one of them on my number line? Let's start with Ellen, 7/4.
So each one is one jump is 1/4.
Good.
So if you jump 7 times, that will equal 7/4.
Good. So let's start at 0/4, and I'm going to go ahead and make 7 jumps like you said. And I'm not going to label it, but I will count it. So 1/4, 2/4, 3/4, 4/4, 5/4, 6/4, 7/4. And how can I show that that's Ellen's distance?
Ellen's distance is 7/4 away from the yard.
So what would I put here so that people know that
7/4.
Okay, I could put 7/4, and I'm going to put her name. Okay, and now I'm going to use the bottom of my number line to do Ethan's. So how many jumps do I have to do for Ethan's desk?
3 jumps.
Good. So I start at 0/4, 1/4, 2/4, 3/4. And that's Ethan. Okay, so if this is the wall here, Ellen's desk is 7/4 yards away and Ethan's desk is 3/4 yards away. Okay, B, whose desk is farther from the wall and how do you know?
Well, Ellen's desk, because as you see in the number line, Ellen's desk is 4 more jumps away from Ethan's desk, so it is farther.
Good job. So Ellen's desk has more parts, it has a 7 in the numerator, than Ethan's desk, who only has 3 parts, or a 3 in the numerator. So Ellen's desk is farther. And Tyler went as far as to say, oh, look at that. It's 1, 2, 3, 4 extra parts further. Very good. And what symbol would I put? 7/4 is blank to 3/4.
Is greater than.
Greater than. So my symbol actually faces the opposite way than my other symbol did. and it's greater than. Okay, great job. Now, I do have one question. What do you notice about the fraction 7/4?
That it is bigger than 1 whole.
And how do you know that?
If the numerator is bigger than the denominator, it is bigger than 1 whole.
Very good. So this on my number line is representative of 1 yard, and Ellen's desk is actually further than 1 yard. It's between 1 yard and 2 yards. Okay, good job. Now, you know how I love to bake, right?
Yep.
So let's take a look at my baking. I went ahead and I baked 2 cookies, and I'm going to go ahead and I'm going to break that into fourths, and I'm going to break each one of them into 4 equal parts. So I'm going to take my first cookie, and I'm going to cut it like this, and now I'm going to take my second cookie, and I'm going to cut it like this. If I shade in 2 of these parts, and I shade in 1 of these parts, can you tell me in fourths how many fourths I shaded in for my first cookie?
You shaded in 2/4.
I shaded in 2/4. And what about on my second cookie? How many fourths did I shade in?
1/4.
I shaded in 1/4. Well, looking at these cookies, this part right here is smaller than this piece right here. So 2/4 is less than 1/4. Do you agree?
Yeah, no, I don't agree.
Why not?
They are different sizes.
What's a different size?
The 2 cookies and the whole.
The whole is 2 different sizes. So what's really important, boys and girls, I cannot compare these 2 cookies this way. I can't compare fourths when the whole is a different size. So in order to do that, I have to take 2 cookies that are the exact same size. And now I can break them up into fourths. Okay, and now in the first one, I'm going to shade in 2/4. And in the second one, I'm going to shade in 1/4. And now I can accurately compare 2/4 and 1/4. So Tyler, which one is actually greater, 2/4 or 1/4?
2/4.
2/4 is greater than 1/4. Good job. Boys and girls, please remember that's really important. If you're creating your own models, please make sure that every time you draw a new whole in the same problem, that it's the same size and that you're breaking them up in the same way to compare the fractions. So let's take a look at the step it out. And remember, as I read the problem to you, you're making a mental image of what the problem is about. Len uses 5/8 of a wooden board to make a roof for a tree house. Raylette uses 7/8 of the same size board to make a chair. Who uses more of their board? Show where Len and Raylette cut their boards. So what are you picturing that is going on with the situation? Well, I'm picturing 2 people, and they each have a piece of wood. They're the same size. That's really important. Okay, and one of them is making a roof for a tree house, and the other one is making a chair. Now looking at the quantities, I see the quantity 5/8. And the 5/8 represents the amount of wood that Len is using. And then I see 7/8. And the 7/8 represents how much of the board Raylette uses. And if you take a look at the right, you see the 2 pieces of same size board. Now, our boards are already broken up into equal parts. Any idea how many equal parts each board is broken up into? That's right, 8. 8, because our denominator for both of our fractions is an 8. So I know that I need 8 equal parts to make each whole board. I'm going to label them just to make it easy, and I'm going to put Len here, and Raylette, we'll call her Ray, on that side. Len uses 5/8, and Raylette uses 7/8. And I like to label my models to make it easier for me when I'm solving my problem. So I'm going to go ahead and find 5 parts out of the 8 for Len. So 1, 2, 3, 4, 5. So he's going to cut his board right here. And Raylette is going to use 7 out of those 8 parts. 1, 2, 3, 4, 5, 6, 7. She's going to cut right here. Now, just so that we don't get confused, I'm going to cross off what they're not using. Okay, so the rest of the board they are using. So I see that Len uses this much and Raylette uses this much. So A, when equal-sized wholes are divided into the same number of equal parts, the denominators are the same. So each of those boards was divided into 8 equal parts. So we notice that our denominator for each of those fractions is the same, an 8. You can look at the blank to compare the number of parts being counted. What part of the fraction tells me how many parts we're counting? That's right, the numerator. Each whole board has 8 equal parts. Now you compare the numerators. Blank parts are more than blank parts. So 5 parts or 7 parts? 7 parts are more than 5 parts. So 7 is greater than 5. So 7/8 is greater than 5/8. Boys and girls, since the denominators are the same, I can just compare the numerators to see the number of parts that I'm counting. If I'm counting 7 parts out of 8, that's more than counting 5 parts out of 8. So who uses more of their board? Raylette does. To compare fractions with the same denominator, how do the numerators tell you which fraction is greater? Well, the bigger the numerator, the bigger the fraction. So if the denominators are the same, the numerator that's greater is the fraction that's greater. Okay? Okay, boys and girls, now it's your turn. You're going to pause the video here in a minute to complete the check understanding and the on your own. When you're finished, you're going to come back to the video so that we can review them together. So please pause the video and get to work. Hi guys, welcome back. Let's see how we did. So let's start with the check understanding. Number 1, on Tuesday, it rains 3/4 inch. On Wednesday, it rains 2/4 inch. On which day is there more rain? Draw a visual model to justify your answer. So we're comparing 3/4 inch on Tuesday and on Wednesday, 2/4 inch. And we want to know the day where there was more rain. So we want the greater fraction. And it asks us to draw a visual model to justify our answer. But before we do that, let's look at the two fractions side by side and see what we notice. So we have 2/4 and we have 3/4. Here's what I notice. I notice that the denominators are the same. That means that in each of my wholes, they're broken up into 4 equal parts. So those parts are going to be the same size or the same amount. So now I can compare my numerators. I have 2 parts or 3 parts. I know that 3 parts is greater than 2 parts, so 2/4 is going to be less than 3/4. And to prove that to you, I'm going to draw a quick model right here. And you're going to notice that as I draw this model, I'm going to draw two holes, and I'm making my holes the same size. And that's really important in order to compare those fractions. And now I'm going to go ahead and I'm going to divide each of my fractions into four, or each of my holes into 4 equal parts. And I tried lining up the parts right on top of each other so that I can compare it easily. So now I'm going to go ahead and I'm going to write, a T for Tuesday, a W for Wednesday, and on Tuesday I'm going to shade in 3/4 or 3 of those parts. And on Wednesday I'm going to shade in 2 parts or 2/4. And by looking at my shaded parts, I see that 3/4 is bigger than 2/4. It has 1 extra part shaded. It has 1/4 more shaded than 2/4. Number 2, on your own, construct arguments. Lisa has 2 same-sized pizzas. She says 3/8 of one pizza is greater than 5/8 of the other, because each of the 3 equal parts in 3/8 is larger than each of the 5 equal parts of 5/8. Is Lisa correct? Explain your answer and draw a visual model to show your reasoning. Well, boys and girls, that's a whole lot of words. I know that Lisa has pizzas, and I do see that the pizzas are the same size. And if I look at my fractions, they each have a denominator of 8, which means that I'm taking my pizzas and I'm going to break them up into 8 equal parts, each one of them. And I'm trying to copy each other so that my parts are very close together in size. Okay. And now she has 3/8, so she's going to go ahead and shade in 3 parts. And she also has 5/8. So she's going to shade in those 3 parts, that's 3/8. But how many more parts does she have to shade in order to make 5/8? Yeah, 2 more parts. So 1, 2. So now we have 5/8 and 3/8. And Lisa thinks that the 3/8 is greater than 5/8. Do you agree? Why or why not? I disagree, boys and girls. I disagree. I don't think her thinking is correct, because since all of the parts are the same size, my denominator is the same, so now I can compare the parts that I'm counting, my numerator. 3 parts out of 8 is less than 5 parts out of 8. Compare the fractions. Write less than, greater than, or equal to. 3/8 and 5/8. I see that their denominators are the same, so now I can just compare my numerators. What is greater, 3 parts or 5 parts? 5 parts. And we see that this problem actually corresponds to the 2 pizzas up there. Number 4, 5/6 or 4/6. Well, let's check our denominators. Oh, they're the same. So if the denominators are the same, the parts are all the same size. So now I just compare my numerators. 5 parts or 4 parts? Well, 5 parts is greater. Number 5, 5/3 and 5/3. My denominator is the same, so now I compare my parts that I'm counting. 5 parts or 5 parts? Well, that's easy, they're the same. So 5/3 is equal to 5/3. Number 6, Remy's family eats 2/6 of a carrot loaf and 3/6 of a pumpkin loaf. Both loaves are the same size. Which loaf has less left over? Explain. Now, boys and girls, this is one of those tricky problems that if you've been following along really well and you've been getting all the problems right, it's very easy to answer the wrong question here. So let's work through it and see what the misconception could be here. So I know that I'm comparing 2/6 and 3/6. And we're talking about how much cake they're eating. So they're eating 2/6 of a carrot loaf and 3/6 of a pumpkin loaf. And they are both the same size. So I'm going to go ahead and draw a model. Let's see if I can divide this into sixths. Okay, and the top one is going to be my carrot. And the bottom one is going to be my pumpkin. Now, the common misconception here, boys and girls, would be that students would say they ate 3/6 is greater, so the pumpkin loaf is greater. But I want you to pay attention to the question. The question is, which loaf has less left over? So what I'm going to do in my model is I'm actually going to put an X for what they ate. So we know that they ate 2/6 of a carrot loaf. So they ate this part, so it's no longer there. And they ate this part, so it's no longer there. And the rest is left over. And then for my pumpkin loaf, they ate 3 parts out of 6. So I'm going to cross off 3 of those parts. Okay, and the rest is left over. So this right here is actually the fraction or the part of the loaf that is left over for each one. So for the carrot cake, I have 4/6 left over. And for the pumpkin, I have 3/6 left over. So which loaf has less left over? That's right, the pumpkin has less left over. Okay, great job, boys and girls. So boys and girls, to wrap up today's lesson, let's remember a few points. When you're comparing fractions, you have to make sure that the wholes are the same size. This is especially important if you're creating models. Make sure that you're drawing them the same size and shape. If your denominators are the same, please compare the numerators. You're just comparing the parts that you're counting at that point. Okay? And if all else fails, boys and girls, and you're having a hard time, just stop and draw a model. They can look like bar models. You can use number lines. You can use any of the strategies that we've used. So I'm sending you virtual hugs from here. And we all know that Olaf loves warm hugs. So please send me some love and like the video and subscribe to the channel. Okay, so boys and girls, today for your Nearpod activity, you have 5 multiple choice questions and you have an open-ended question. Please prove your thinking to me in your open-ended question. You can type your answers or you can record yourself explaining to me if you agree, disagree, and why. So for English, your code for Nearpod is EHTAO. Para os meninos que falam português, o vosso código está na computadora, PLVJB. Y para los niños que hablan español, el código está en la computadora, LCSGP. And now a word from Tyler.
Don't forget to like and subscribe.
Good job, Ty. I will see you tomorrow, boys and girls. Be safe, stay healthy.